Hey, I'm Jared from Shaping the Silence, and in this video we're going to be working on the fog machine and getting these stage lights working. So I'm out here on my back porch again because today I got the new pump in the mail for the fog machine, so let's go ahead and see if we can get this thing working again. As you saw in the last video, the fog output was pretty pathetic, and it even got worse after I stopped filming, so that's what I'm trying to fix right now. Let's see if we can make it better. Before I try this thing out, I do want to mention the pump that I'm replacing is much bigger than the little tyke I used in here, so not sure if that'll work. I just kind of had to go with what I could find. So I found a cheap pump on eBay to see if it works. So I've been having issues with this thing. Apparently the new pump that I got does not work with the old triggering mechanism for setting it off. This could end poorly. I think a couple outcomes for this are I get shocked, the pump blows up, the pump leaks, or it works. Let's give it a try. Wait, that's something. Obviously not there yet, but we're getting closer. As you saw in the video, the results from the new pump were absolutely disappointing. So what I instead did was take the old pump and tear it apart and see if I could figure it out. Here is the complete pump all exploded into different pieces. When I opened it up, the thing was corroded. So what I did was take these parts, put them in a water and white distilled vinegar mixture for about a half an hour, and then scrub the corrosion off. After a lot of off-camera suffering, I was finally able to get the pump working in this thing, so here's my first test of the actual thing fully assembled. Forget it. After that disheartening episode, I decided to change things up and try working on the stage lights for a bit. As things usually go, it ended up being a bit more complicated than I thought. I got the lighting working, but it didn't take long before disaster set in. I was testing out the lights, and it seemed to be working well. I had a MIDI loop program to make them light up different patterns and stuff like that, when all of a sudden the USB device started disconnecting and reconnecting to my computer and causing all sorts of problems. So I didn't know quite what was up, but by the time I checked on the chip, this thing was hot to the touch and it's toast. I unplugged it from all the rest of the electronics, tried plugging it into my computer, doesn't recognize it. I can't reprogram it. This thing is dead, so that's $20 in the trash. I should probably say that's a $20 lesson I learned. The first thing that came to mind was that I'm like Icarus. You know, I flew too close to the sun, my wings melted, and everything stopped working. Besides that, I've been struggling with the fog machine over the last week, and I just feel like I've been taking a whole lot of L's lately. Sometimes life is just kind of like that. You know, what I have to do is get back up and keep working on this project, because if I don't, I'm just going to be miserable. Lots of things happen. It's okay. I'm saying this for my benefit, by the way. While I wish I didn't make this mistake, I need to take the opportunity to learn from it. I don't exactly know why this thing burned out. I'm guessing that it has something to do with the 30 volts that powers the light somehow backfeeding into the circuit here. I think what I'm going to try doing is figure out what's the best way I can isolate the high voltage lighting from the low voltage electronics. So in my current setup, I have the Teensy, which is the brains of the whole thing, connected to the PWM controller, which essentially controls the brightness of the LEDs by turning on and off really quickly, like 1,000 times a second on and off for different lengths to adjust the brightness. Now that pulse is sent at 3.3 volts. So the Teensy runs off of 3.3 volts. The PWM controller runs off 3.3 volts, and it sends a 3.3 volt signal up to the LED driver. Now the LED driver takes that signal and uses it to turn the light on and off really quickly to adjust the brightness, and the LED driver runs off of 30 volts. 30 volts is supposed to just go up to the LED, but I think we're having a problem where the 30 volts decides to take a journey back on down this way, killing the PWM controller and killing the Teensy in the process. What I need to do is figure out a way to separate these two at this place, so that way there is no way that the 30 volts here can touch any of these sensitive electronics. One of the tricky things with figuring this out is I have to find a solution that can switch on and off 1,000 times a second. If the thing that isolates these two cannot switch that quickly, then it won't work at all. I'm going to start researching and figure out what I can use. I think I have a couple of options here. Here is the new design. As you can see, I have a new little module in the middle. So we have the Teensy, the PWM controller running off 3.3 volts and sending a 3.3 volt signal to the opto isolator here, or optocoupler. That connects to the LED driver, which controls the LED running off of 30 volts. I'm going to show you how this optocoupler works. Let me give you a blown up view. This is how big the actual thing is. It's very small and has 4 legs coming off of it. So we got these 2 up here, these 2 down here. On the inside of here, essentially, we have a light source. On this side, we have a material that reacts to the light by allowing current to pass through. So on one side, we have positive and negative here, and that turns on this light. So this little light, in turn, allows electricity to pass on this side. Let's say you have a battery over here, a light bulb. So you got a light bulb here. It turns on when the light's on here. Turning on power to this side activates a switch on this side. The important part here is that there are no wires connecting this side to this side. If I was to have like a zap of electricity hit this side of the circuit, it would not go over to this side because it's not connected with wires. There's actual space between the electrical components inside this little thing. This tells this what to send out. This sends out the pulsed signals to the different opto isolators, and then this switches on and off really quickly, controlling the driver. Anyway, that's enough talking about it. Let's go ahead and throw together a prototype, see if this thing actually works. Now, I thought that this would be it, but there were some more design deficiencies that needed to be addressed. I finally got the stupid thing working, but not before burning out my LED driver that I was gonna use to test it. So I'll see if I can hook it up to one of my main lights instead. Okay, I've got a new setup. Let's see if this blows up when I plug it in. And go. So far we're having no effect. Wait a second, I got it working. I don't know if you can tell what's going on, but color's fading, which means that this system works. Now I have an optically isolated circuit, meaning the high-powered LED is completely separate from the low-powered electronics. Now I need to take this out of the prototype phase and make it into a more permanent fixture. I think I actually figured out what caused the problem. So by connecting my voltage tester to the LED's control lines, I'm actually able to see that there's a voltage spike that gets sent back when the LEDs power on. So when I plug it in, it kind of sits around 5 volts. So, you know, that's generally safe for my stuff. But if I turn the lights off and on a few times, you might see that registers like upwards of 30 volts for brief periods, and that's plenty to burn out my electronics. While it's safe when it's running, it's not safe on startup and shutdown. Now I know that this is for sure the issue. I'm glad to have this resolved. With repeated testing, plugging this thing and unplugging it really quickly, I actually burnt out the drivers in here, so I don't know, man. I'm about to redesign this whole thing and use different drivers for these lights because apparently they don't seem up to the job. Well, you know, as they say, when you release too much magic smoke, sometimes it's just time to call it a day. So I'm going to go to bed, rest up. I'll be doing better tomorrow. Now, I've been able to protect the 3.3 volt electronics from the 30 volts of the LED driver by optically isolating it from the rest of the circuit using this optocoupler here. Now that this is safe though, I found a new problem. I need to protect the LED driver from itself. Let me go ahead and get a new piece of paper so I can explain what's going on. Here I have a rough drawing of the LED driver. So on this side we have the power source, which goes into the input, so positive and negative there, and then we have the output side, which goes into the LED, which will then light up. Bam, bam, bam. Now where it gets complicated is this dimming pin here. Now see, this pin outputs 5 volts, but when it's connected to the ground, so the negative here, it turns the LED off. When it's not connected to the ground, the LED is on. What I'm doing with the switch is I'm connecting it to the ground on and off really quickly to adjust the brightness of the LED. Now normally this thing is outputting about 5 volts. However, when I turn on the device, for a brief moment, it's up to about like 45 volts. Let's see here, we have the opto isolator here. Boink, 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 boink. This here turns on and off the connections. It's like a switch on here that's allowing the power to pass through the dim pin to the ground. and it can be on and off depending on if this side is on or off. Now, when that 45 volt spike happens at the beginning of powering this device on, if this side happens to be on, it will allow 45 volts to pass from this pin through the opto isolator and into the ground, and that allows this device to blow itself up. I think the simplest solution would be to connect a resistor in here to lower the amount of current that could possibly go through here in case of that 45 volt spike. Now, I don't know if this solution is going to work, but I think I'm going to give it a try as it is the simplest, and if it works, then perfect. Unfortunately, while repairing this thing, I was not careful and I accidentally tore off a couple solder pads for this chip that I'm replacing. Gotta be more careful next time. I don't have many of these left. I was somehow able to get this thing working again. I had to reroute a couple of the wires to bypass the torn traces, but this is going to be my test platform to make sure my safety mechanisms are in place correctly. So, light is powered on when I give it power. When I connect the dim pin to the ground, it turns off. Based on what I've tested so far, if I was to connect this dim pin to the ground and then connect power, I might have the chip blow up if it has that voltage spike, which it has been having. In order to mitigate that, I think I'll put a resistor between this wire and the ground connection. Now, as a correction, I need to point out that it's actually a 35 volt peak that I was able to hit, not 45 volt peak. But anyway, at 35 volts, even if there was a resistance of 1 ohm, I would end up with 35 amps being drawn through this. Now, that's actually impossible because the power supply I have can supply 10 amps at 35 volts. So I would end up actually pulling the maximum through the power supply no matter what happens. So that spike would actually take the full 360 watts of power that the power supply is generating and force it through this small chip for a split second, and that's enough to pop the thing. With this 10 kilo ohm resistor, I'm actually able to reduce that significantly. So when I connect this to ground, it still turns the light on and off, which is exactly what I need. But if you take, 35 volts and you divide that by 10,000, you end up with 3.5 milliamps. That is significantly less power going through here, and that won't even come close to being able to damage it. I hope. Let's find out. It's not working, so I'm wondering if I possibly toasted this little boy. Let's see if I can get it working with a new one. Oh, there it goes. Perfect. So it's fading up and down in brightness. That's fine, but now I need to try it with the resistor in place, and if it works with the resistor, then I think I have a solution. Okay, so this is now working with the new resistor in place to protect it from frying itself. Here's the test. What I need to do is disconnect and reconnect the power very quickly. Here's my connector for the main 36 volt power supply. If I disconnect and reconnect it, it'll burn out this chip if this doesn't protect it. Let's give it a try and see what happens. Oh my goodness. It's working. Oh, this is exciting. I have found a solution to protect the lights from burning themselves out, and I found a solution to protect the rest of my electronics from being burnt out. So the next step is to come up with a way of laying this all out and getting everything put together nicely. Alright, I got the lighting board complete. I'm really happy with how it turned out. It's nice and clean, and I have all of the optocouplers on sockets, so in case any of them get blown up or whatever, I can just pop it out, pop on a new one. So now I just take the PWM controller, connect it to this right here, and there we go. That's the completed unit. Now I just gotta take this and connect it to my lights. Since I burned out the last teensy I had to jerry-rig something with another controller. It's all wired up into my board. Here's the lighting piece, and I'll show you how it operates. Here I have some MIDI that I'm sending out to the dance pad to control the lights. The kick sets off the blue light, the snare sets off the red light, and the hi-hat set off the green light. Here's what it looks like. That's cool and all, but earlier I blew up a driver on one of my lights, so let's fix that one up. Here's the chip that I burned out. You can see a little bump on it, and we can move on over. I have replaced it with a new one. All right, much better. Now let's reassemble the thing. I got my lights working again, so epilepsy warning and stuff. Thank you so much for taking the time to get to the end of the video with me. I do appreciate having you here. If you enjoyed this video, please be sure to leave a like on it, and don't forget to subscribe and hit that bell so that you can get updated every time I upload a new video. As always, your comments are appreciated. I read every single one of them, and I'll do my very best to answer any questions you have for me. If you'd like to support this project, all I ask is that you share this video with people you think would be interested, and check out my music. Links in the description. I'm really excited about where this project is going. We've made some good progress on it these last 2 weeks, and I'm super excited for what the future has in store for us. Anyway, you guys have a great rest of your day, okay? Love you. Bye.